Now, example 11.12 says an electric bulb is connected to a 220 watt generator. The current is 0.5 ampere. What is the power of the bulb? So, here I am given V equal to 220 watt, I equal to 0.5 ampere. So, power will be equal to VI. So that is 220 into 0.5. So that will be 110 watt. Now example 11.13 says an electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate for 30 days at rupees 3 per kilowatt? So here I am given P equal to 400 watt and P equal to nothing but energy upon time. So energy is in kilowatt. So energy will be equal to P into T. So that is 400 upon 1000 into 8 because I have converted it into kilowatt. So that will be equal to 3.2 kilowatt per day. Now per day it is generating 3.2 kilowatt. So if I want to do it for 30 days, 3.2 into 30, so that will be 96 kilowatt per hour. Now cost per hour is cost per kilowatt is rupees 3. So therefore cost for 96 kilowatt hour will be rupees 96 into 3. So that will come as rupees 288. Now 192 page second numerical says an electric motor takes 5 ampere from a 220 watt line. Determine the power of the motor and the energy consumed in 2 hours. So I equal to 5 ampere, then potential difference V equal to 220 watt. So P will be equal to VI. So that will be 220 into 5. So that will be 1100 watt. So which will be equal to 1100 upon 1000 kilowatt. So this 2 gone, so kilowatt. So that will be 1.1 kilowatt. Now energy will be equal to power into time. So that will be 1.1 into 2 kilowatt hour. So that will be 2.2 kilowatt hour. Now let us discuss the exercise numericals. The first one says a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then ratio R upon R dash. So see, we know that resistance R is directly proportional to length. So therefore R is directly proportional to L, and here I have break the R into 5 equal parts. So R equal to R upon 5. So 1 part resistance, if I talk, it will be R upon 5. Now they are connected in parallel. So I can say 1 upon R dash, that is parallel, equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, so on. So here if I see, it is 1 upon R by 5 plus 1 upon R by 5, all are of the same values. So all the 5 resistance are of the same value. So if I reverse them, that is denominator if I take up, so it will be 5 upon R plus 5 upon R plus 5 upon R plus 5 upon R plus 5 upon R. So that will come as 25 upon R. So therefore 1 upon R dash equal to 25 upon R. 25 upon R. So therefore I can say R upon R dash will be equal to 25 upon 1. I have just cross multiplied to get the answer. Now the third question says an electric bulb is rated 220 watt and 100 watt. When it is operated on 110 volt, the power consumed will be how much? So here power is 100 watt, V is 220 watt and V equal to 110 watt. So see, I can say P equal to V square upon R. So 100 will be equal to 220 into 220 upon R. So therefore R will be equal to 220 into 220 upon 100. So that will be equal to, therefore R will be equal to 22 into 22. Now he has said power, so P equal to V square upon R. So V is 110 into 110 and R is 22 into 22. So if I cut 22 ones are 22 fives are 22 ones are 22 fives are. So this will be 5 into 5. So P equal to 25 watt. Next is two conducting wires of the same material and of equal length and equal diameters are first connected in series, then in parallel across the same potential difference. The ratio of heat produced in series and parallel combination will be dash. So see, H will be equal to I square RT. So in series, R will be equal to R1 plus R2 and so on. So here R equal to R plus R. So that will be equal to 2R. So I will be equal to V upon R. So I will be equal to V upon 2R. Now H series will be equal to I square RT. So that will be equal to V upon 2R into V upon 2R into 2R into T. So 2R cancel. So this will be V square T upon 2R. And when in parallel, 1 upon R equal to 1 upon R1 plus 1 upon R2 plus so on. So here 1 upon R will be equal to 1 upon R plus 1 upon R. So that will be equal to 2 upon R. So therefore R will be equal to R by 2 in parallel. So now HP will be I square RT. So that will be 2V upon R into 2V upon R into R by 2 into T. So that will come as 2V square upon R into T. So now he has asked me the ratio. So HS upon HP will be equal to V square T upon 2R whole upon 2V square upon R into T. So that will be V square upon 2R into R upon 2V square. So V square cancel, R cancel, so that will be 1 upon 4. So therefore I can say HS is to HP, that is ratio of series to parallel will be 1 is to 4. Now the sixth numerical says a copper wire has diameter 0.5 mm and resistivity of 1.6 into 10 raised to minus 8 ohm meter. What will be the length of the wire to make its resistance 10 ohm? How much does the resistance change if the diameter is double? So here D is given as 0.5 mm. So if I convert it into meter, it will be 0.5 into 1 upon 1000 meter. So that will be equal to 0.5 into 10 raised to minus 3 meter. So I can say R will be equal to 0.5 into 10 raised to minus 3 upon 2 meter. Now resistivity is 1.6 into 10 raised to minus 8 ohm meter. R is 10 ohm, sorry. So now I need area also. So to find area, I will use the formula A equal to pi r square. So that is equal to 3.14 into R is 0.5 into 10 raised to minus 3 whole square upon 2 square. So this values now I am using in the formula. R equal to resistivity L upon A. So therefore L equal to R upon resistivity into A. So that will be equal to, now I am placing all the values. So R was 10 into 3.14 into 0.5 into 10 raised to minus 3 into 0.5 into 10 raised to minus 3 whole upon 1.6 into 10 raised to minus 8 into 2 into 2. So if I cut 2 and 10, so that will be 5, and if I cut with 2, 3.14, I will get 1.57. So that is coming to 5 into 1.57 into 0.5 into 0.5 into 10 raised to minus 6 plus 8 upon 1.6. So that is 5 into 1.57 into 0.5 into 0.5 upon 1.6 into 10 raised to 2. So now I am removing the point from 1.57 also. So 157 upon 100 into 5 upon 10 into 5 upon 10 into 10 square. So that is coming to finally 122.6 meter. So I got L equal to 122.6 meter. Now in the second case he is saying if D becomes 2D, so therefore R will be equal to 2R and A will be pi r square. So that is equal to pi into 2R whole square. So that will be 4 pi r square. So R is directly proportional to L upon A, or R is directly proportional to L and R is inversely proportional to A. But here I don't need L, so I am writing there 1 because I have to just check the R and A. So R is inversely proportional to A. So resistance will be decreased by 4 times, because 1 upon 4 means it will be decreased. Now, 8th numerical says, when a 12-watt battery is connected across an unknown resistance, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So, here if you see carefully, I am given V equal to 12 watt. I is given as 2.5 milliampere. So that will be 2.5 into 10 raised to 3 ampere, because 1 milliampere equal to 10 raised to 3 ampere. So now we know that the formula is V equal to IR. So therefore R will be equal to V by I. So putting the values, I will have 12 upon 2.5 into 10 raised to 3. So that will be, if I remove point from the denominator, it will become 120 upon 25 into 10 raised to 3. So that comes as 4.8 into 10 power minus 3 ohms. Therefore, resistance equal to resistance of the resistor is 4.8 into 10 raised to minus 3 ohms. Now, 9th numerical says a battery of 9 volt is connected in series with resistor of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? So, here I am given V equal to 9 watt, R1 is 0.2 ohms, R2 is 0.3 ohms, R3 equal to 0.4 ohms, R4 equal to 0.5 ohm and R5 equal to 12 ohms. Now they are connected in series. So series current is always same. Current will be same. So Rs will be equal to R1 plus R2 plus R3 plus R4 plus R5 and so on. So here 5 resistances are there. So 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So that comes to 13.4 ohm. So now I equal to V by R. So here it will be equal to 9 by 13.4. So that will be 90 by 134. So that is coming, if I cut with 2, 45 upon 67. So if I divide it, finally I will get 0.671 ampere. Now 10th numerical says how many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line. So here I is 5 ampere, V is 220 watt and number of resistors I have to find. Now first of all, R will be equal to V upon I. So that will be 220 upon 5, so that is 44 ohm. So therefore total R should be 44 ohm. Now we know that in parallel 1 upon Rp equal to 1 upon R1 plus 1 upon R2 and so on. So here 1 upon 44 should be equal to 1 upon 176 into number of resistors, because here the resistance is same of all resistors. So number of resistors will be equal to 176 upon 44. So if I cut them, I am getting directly 4. So therefore number of resistors will be 4. Now 11th numerical says, show how you connect 3 resistors, each of resistance 6 ohms, so that the combination has a resistance of first 9 ohms, second 4 ohms. So if 2 resistors are in parallel and third in series, so 1 upon Rp will be equal to 1 upon 6 plus 1 upon 6. So that will be 2 upon 6. So that will be 1 upon 3. Therefore R equal to 3 ohms. Now when they are in series, Rs will be equal to R plus R. So the resistance which was in parallel, 2 were in parallel, so its resistance is 3 and the other one is 6. So 3 plus 6 will give 9 ohms. And in the second case, let Rs equal to 6 plus 6. So that will be 12 ohm. So here 2 are in series. Now 1 upon Rp equal to 1 upon Rs. The two ones are series are connected here in parallel with one parallel. So this will be 1 plus 1 upon 12 plus 1 upon 6. So that will be LCM will be 12. So 1 plus 2. So 3 by 12. So that will be 1 by 4. So therefore Rp equal to 4 ohms. So therefore 2 are in series and 1 in parallel are connected. Now next question says, several electrical bulbs designed to be used on a 220 watt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 watt line if the maximum allowable current is 5 ampere? So P is 10 watt, I is 5 ampere and V is 220 volt. So first V equal to IR. So R will be equal to V upon I. So that is 220 upon 5. So 44 ohms. So now one bulb resistance equal to, I have to find. So P equal to V square upon R. So R will be equal to V square upon P. So that will be 220 into 220 upon 10. So that is coming as 22 into 220. So 4840 ohms. Now total resistance is 44 ohm when one bulb resistance R equal to 4840 ohm. So 1 upon R equal to 1 upon RB in N. So RB is the bulb of one bulb. So here 1 upon 44 will be equal to 1 upon 4840 into N. So N will be equal to 4840 upon 44. So that will come as 110 bulbs. So I can connect 110 bulbs. Now 13th numerical says a hot plate of an electric oven connected to a 220 watt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in the three cases? So here first V equal to 220 watt. So RA is 24 ohms, RB is also 24 ohms. So V equal to IR. So I will be equal to V upon R. So that is 220 upon 24. So that comes as 9.1 ampere when separately used. Now when I am using them in series, RS will be, or R series will be 24 plus 24. So that will be 48. So I will be equal to V by R. So that will be 220 upon 48. So that will be 4.5 ampere. And when in parallel, again here 1 upon RP will be equal to 1 upon 24 plus 1 upon 24. So that will be 2 by 24. So that will be equal to 1 by 12. So RP will be equal to 12 ohms. So I will be equal to V upon R. So that will be 220 upon 12. So that will be 18.33 ampere. Next question says compare the power used in the 2 ohm resistor in each of the following circuits. A 6 watt battery in series with 1 ohm and 2 ohm resistors, and second a 4 watt battery in parallel with 12 ohm and 2 ohm resistor. So first V equal to 6 watt in series. So I will be equal to V by R. So that is 6 by 3, because 1 plus 2 will be 3. So 2 ampere. So now P equal to I square R. So that will be 2 square into resistance is 2. So 8 watt. Now in the second case V equal to 4 watt, and here parallel I have arranged. So P equal to V square by R. So that will be 4 square upon 2. So 16 by 2. So that is watt. Now next question says two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to series main supply. What current is drawn from the line if the supply voltage is 220 watt? So here L1 P equal to 100 watt and V equal to 220 watt. So parallel I will be equal to question mark. So P equal to VI. So I equal to P by V. So that is 100 upon 220. So that is 0.45 ampere. Now, when in series, that is L2, E equal to 60, V equal to 220 watt. So P is VI. So I equal to P by V. So that will be 60 upon 220. So that will be 0.27 ampere. Now total current they have asked. So total current will be equal to 0.45 ampere plus 0.27 ampere. So that comes as 0.72 ampere. Now next question says, which uses more energy, a 250 watt TV set in 1 hour or a 1200 volt toaster in 10 minutes? So P equal to energy upon time. So energy will be power into time. So TV power will be 250 watt. T equal to 1 hour. So that is 3600 seconds. So energy will be 250 into 3600. So that will be 9123450. So that is 9 into 10 raised to 5. Now for toaster machine, P is 1200 watt and T is 10 minutes. So 10 minutes means that will be 10 into 60 seconds. So 600 seconds. So energy will be P into T. So that is 1200 into 600. So that comes as 721240. So that will be 7.2 into 10 raised to 5. So therefore TV draws more energy. Next question says, an electric heater of resistance 8 ohm draws 15 ampere from the service mains in 2 hours. Calculate the rate at which heat is developed in the heater. So here R equal to 8 ohms, I equal to 15 ampere and T equal to 2 hours. So power P equal to I square R. So that is equal to 15 into 15 into 8. So that will be 225 into 8. So that comes as 1800 watt.